Hi, welcome back to the review for Chapter 5 from Course 1A Singapore Math. We are doing review, which means we have done all the sub chapters. Wow, I'm sure you've watched the content videos and independent practice for each of these chapters before doing this review with me. Have you? Yes? Great. So let's begin the review. Question 1. A factory produces 300 video game discs in 15 minutes. How many video game discs can it produce in 1 minute? So we know that 300 can be produced in 15 minutes, right? And we got to find for 1 minute. So it's basically dividing this 300 divided by 15, which is how much? If you do this calculation here, 15 goes once and 15 goes twice in 30, right? And this 0 comes there. So the answer is 20. Okay, time for the next. Carolina is paid $336 for 7 days of work. How much is she paid per day? So whenever you have to find unit rate, you just do simple division, right? So this is 336 for 7 days. And to find for 1 day, we divide by 7. Let's do the division here. That's times 4 is 28. That gives the remainder of 5, and the 6 comes down, and 7 times 8 is 56. So she is paid $48 per day. Third, a printer can print 25 pages per minute. 25 pages per minute. At this rate, how long will it take to print 2000 pages? So we have pages here, right? And that's the time here. So 25 to 2000 is how much? Let's do the division here. If this is 200, 25 times 8 is 200, right? And the 0 comes here. So that's times 80. So the same thing on the other side. This is times 80. So we say this also to be times 80. So it's going to take how long? 80 minutes. Next, an empty bathtub is filled with water at a rate of 2.5 liters per minute. 2.5 liters per minute. How long will it take to fill the bathtub with 30 liters of water? So, what's this? 12, right? Because 2.5 times 10 would give us 25. So, the same thing here times 12. So, it's going to take 12 minutes. Done. Two-third cup of oatmeal is needed to make 10 granola bars. So two-third cup makes 10 granola bars. How many such granola bars can be made with 20 cups of oatmeal? Two-third will make 10. Let's see how much the whole cup will make. So we say 10 divided by two-third. So that's basically 10 times 3 upon 2, right? Division becomes multiplication and the fraction inverses. So that's times 1 and that's times 5. So this is basically 15. So per cup, 15. 1 cup can make 15. This is what? Times 20. The same thing here. Times 20. 15 times 2 is 30. So this is going to be 300 because it's times 20. 5 questions already done. A machine takes 15 minutes to scan 1125 pages. That's 1125 pages. 15 minutes for how many pages? 1125. At this rate, how many pages can the machine scan in an hour? 1 hour. And this is minutes. So we have to be mindful and convert it. Okay. Otherwise, sometimes students will just write 1 over there and they'll just end up having wrong answers. So be careful. 1 hour is 60 minutes, right? So we write here 60. So 15 to 60 is times 4. So the same thing we have to do here times 4. So 1125 times 4. That's 20. So 2 there. 8 plus 2, 10. So 0, 1 carry. That's 5 and that's 4. So it's 4500 pages. Always write a last statement, very important, as an answer. It can scan 4500 pages in an hour. Question 7. 150 grams of fertilizer is required for a land area of 6 square meters. So it says 150 grams for 6 square meter of area. So what does this lead us to? It's 25, right? 6 to 150 is times 25. So 25 upon 1. So 25 grams per meter area. So for every 1 meter area, you need 25 grams of fertilizer. At this rate, how many grams of fertilizer are required for a land area of 13 square meters? This is 1. We need for 13 square meters. So this is times 13. So you do the same thing, times 13. And 25 times 13 is not difficult, right? 25 times 10 is 250. So 275, 300, and 325. So it's 325 grams of fertilizer is required. For what land area will 850 grams of fertilizer be sufficient? For every 1 meter square, we need 25 grams, right? Now, 850 grams will serve how much area is what they're asking. So basically, you do 850 divided by 25, right? That will be 34. You can check here, 850 divided by 25. So that's times 3, 75, 10 remainder, we get the 0 down. So that's times 4. So it will suffice 34 meters square of area. And it's done. Wow. Already on question 8. A machine can stamp 36 bottle caps in 10 seconds. So 36 bottle caps in 10 seconds. Find the missing numbers in the table. So we have this table given to us and we have to fill in the missing information, the missing numbers. 10 is 36. This is what? Times 2, right? So you do the same thing, times 2. 36 times 2 is 72. Then times 3. So you do the same thing, times 3. And that is 108. So it's basically every 10 seconds is 36, right? And this numbers here, the time is increasing by 10 seconds. So it's basically you keep increasing the other side by 36. That's it. So let's just fill this table quickly. 144. Next is going to be 180 and 216, right? Because this will be times 4 times 5 and that's times 6. Okay, this is number of seconds. Last year is 60 seconds, which means that's 1 minute, right? So let's read our question now. At this rate, how many bottle caps can the machine stamp in 5 minutes? In 1 minute, it's 216. So in 5 minutes, it's going to be how much? Times 5, right? So we do 216 times 5. That's 0, 3 there, that's 8, and that's 10, right? So the answer is going to be 1080. Bottle caps can be stamped. At this rate, how many minutes will it take to stamp 24,408 bottle caps? So 216 in 1 minute. 24,408 in how many minutes? So let's see what is this. We divide it here. 24,408 divided by 216. That goes once, 216. Right? So we make this 3, give 1 there, that's 8, that's 2, 28. We get this 0 down, again once, 216. And that's 64 because 64 plus 6 is 70 and plus 10 is 80. And then we get this 8 down. Now 200 times 3 is 600 and 16 times 3 is 48. So this is basically times 3. So we say 113 minutes. Ready for the next? The table below shows the charges for using an internet service. Alex used the internet service for 16 hours and 40 minutes last month. Under which plan would he have to pay less? So we have two plans, plan A and plan B. Which plan is cheaper for him? So we got to do the calculations. Let's do plan A first. We say 16 hours and 40 minutes, right? That's what his usage is. Now it says up to 10 hours. First 10 hours you pay $6, and every subsequent half an hour or part of half an hour you pay $1. So we are going to divide this. So we say this first 10 hours. Okay, first 10 hours, because for that there is a fixed rate of $6. Now, if we take 10 hours out, how many hours are we left here? We are left with 6 hours. And then 40 minutes we will keep here. Okay, so that's an hour, and that's a minute. 6 hours. This is for every half an hour you have $1. So let's convert the 6 hour into groups of 30 minutes. So that's going to be how many? 12, right? Because 1 hour will have two. So 6 hours will have 12. So these are 12 slots of 30 minutes each, right? And that will cost how much? $1 for every slot. And this is 12, right? So that's going to be dollar 12. And 40 minutes is again two slots, right? Because 30 and then additional 10, and it also says part of half an hour, so 10 minutes will be one another slot, right? So that's basically again dollar 2. So this adds up to what? 6 plus 12, 18, 18 plus 2, 20. So that's dollar 20 for plan A. We do the same thing for plan B now. So 16 hour plus 40 minutes. We have to divide again. Here it says up to 12 hours, $4. So first 12 hours is $4. So we write dollar 4. And the same thing, subsequent half an hour or part of it, but this is $2 now. So 12 hours are taken, which means 4 hours are left, right? So 4 hours will make 8 slots, right? And 8 times 2 is $16. Same thing here, 40 minutes. So we'll have two slots here, right? So that's going to be another $4. So the total here is $24. 4 plus 16 plus 4, right? So under which plan would he have to pay less? Under A, because that's 20 and this is 24. Simple. How much less? So we say 24 minus 20, which is $4. So if he uses plan A, he's paying $4 less compared to plan B. That's it. Question 10. A tank was filled with water to its brim at first. Water was then drained from the tank at a constant rate. So the rate is constant here. The line graph shows the volume of water in the tank over 30 minutes. How much water was drained from the tank per minute? To answer this, you can take any information that you feel is easy to work upon. So for me, I see here 15 minutes is exactly here, right? So how much is that? From 300 to 400, we have 5 lines. So each line represents 20. So that's 320, 340, 360, and 380. So this point here is 380. So at 15 minutes, it's 380 liters. And then at 20, again here, it's just come down by 2 here. So at 20 minutes, it has reached 340 liters. I have used these 2 points, but you can use any points. That's not a problem. So let's solve using these 2 points. Now this means in 5 minutes, right? Because 20 minus 15, 5. And 5 minutes, how much is it able to drain? 380 minus 340. So it's able to drain 40 liters. So in 1 minute, how much is it going to drain? Divide by 5. Divide by 5. So it's going to drain 8 liters. And it's done. It was simple, right? Don't let this graph or a lot of information or questions scare you. Look at it carefully. Graphs are really easy to solve. Graphs are visual, which actually helps us solve better. Next part, how many minutes will it take to drain all the water from the tank? So in 1 minute, it's able to drain 8 liters, right? How many liters we have in all? 500 liters. Now, it's asking us how many minutes. This is what we are supposed to find. What's the relation here? So let's solve this here. 500 divided by 8. So that's 648. 2 remainder, 0 comes down. That's twice 16. 4 remainder, we put 0 and a decimal there, and that's 5. So it's basically, to go this way, it's times 62.5, right? So the same thing here, times 62.5, and that's 62.5 because that's times 1 and it's done. So it's going to take 62.5 minutes, right? Question 11. A cyclist rode a distance of 38 miles in 4 hours. So you have distance and you have time. Find the speed. Oh, simple. Speed is distance upon time. You remember your triangle, right? That's distance and that's speed and time. So that's basically 38 upon 4. 38 divided by 4 times 9 is 36. To remainder, we put 0, so that's point and 5. Done. So that's 9.5, and the units will be miles and hours, right? So miles per hour. Next, the speed of a car is 102 kilometers per hour. So we have the speed. How far can the car travel in 20 minutes? So that's time. Now, watch out. Hour and that's minutes. So we are going to convert this first. So 20 minutes to an hour, we divide by 60. We are going smaller to larger unit, right? So we divide. That's 0 out. 2 over 6 is 1 over 3. So that's 1/3 hour. So we find distance, which is speed times time. That is 102 times 1 over 3. 102 is divisible by 3 because 1 plus 0 plus 2 is 3. So that's divide by 3. 3, that's 9. 1 down, 2, that's 4. So it's 34 kilometers. From here I get my units. Question 13. The distance between Sophia's home and the library is 360 meters. So we know the distance. She walked from her home to the library at a speed of 1.2 meters per second. How many minutes did she take for the journey? How many minutes? And this is seconds. Okay, so let's first solve in seconds and then convert it. So time is distance upon speed. So that's 360 upon 1.2. We can write this as 3600 upon 12. And how did I do that? Times 10 and times 10, because then I don't have decimals to deal with. Then we know 12 times 3 is 36. And then this 0. So the answer is 300 seconds. But we want in minutes. So 300 seconds is how many minutes? 1 minute is 60 seconds, right? So basically we have to divide this by 60 to convert it into minutes. So that's going to be 5 minutes. Done. Question 14. Wow. Jessica took 3 minutes to run a distance of 540 meters from point X to point Y. So that's the time and that's the distance. Rachel took 2 minutes to run a distance of 480 meters from point Z to point Y. So that's again time and that's the distance. So we have Jessica and we have Rachel. Distance and time. So that's 540 for Jessica and 3 minutes. For Rachel, it's 480 and 2 minutes. Okay? Find the speed of each girl. We got to find the speed. So we say speed for Jessica. And speed is what? Distance upon time. So 540 upon 3, which is 180. I'll write my units later. And then the speed for Rachel is 480 upon 2 from here, and that's 240. Now, distance is in meters, right? So meter upon time, which is in minutes. So again, the same thing, meters upon minutes. So that's the speed of each of the girls. We can write it here. So that's 180 and that's 240. And the units are same, okay? Which of the two girls ran faster? Who is faster? Of course, this one, right? Because her speed is 240 and this speed is 180. So, Rachel is faster. Question 15. The distance between town A and town B is 45 kilometers. So you have town A and you have town B, and it's 45 kilometers. Okay. If a train travels at an average speed of 60 kilometers per hour, so the speed is here, how long will it take to travel from town A to town B? This is distance here, right? We got to find the time, and time is distance upon speed. So that's 45 kilometers, and the speed is here 60 kilometers per hour. So that's basically, you can write this as 15 times 3, and that's 15 times 4, in which case 15 is out, the common factor, right? So we say that's 3/4 of an hour, which is how many minutes? 3/4 of an hour. So if you have to convert into minutes, they've not asked us to do that, but just to help you understand this concept. So 3/4 of an hour, which is 60 minutes, right? And 4 times 1, 4 times 15. So that's basically 45 minutes. If a train takes 40 minutes, to travel from town A to town B, what is the average speed? So we're going to find the speed in kilometers per minute. Round your answer to one decimal place. Speed is distance upon time, and the distance is 45 kilometers and time is 40 minutes. Kilometers per minute. Okay, so that's very important, otherwise we would need to do the conversion. Now 45 can be written as 9 times 5 and 40 can be written as 8 times 5. So this 5 is out, which means this is 9 upon 8, and you can divide that. So 9 divided by 8 times 1, 8, 1 remainder, you put 0, that's going to be 1, so 8, 2 again there, so we put 0, that's times 2, 16, 4, and then we put 0, so that's going to be 5. So it's 1.125 kilometers per minute. And it says round your answer to one decimal place. So they just want one decimal place, which means we look at the second one, 2, which is less than 5, right? So it is 1.1 kilometers per minute approximately. Okay, that's how you round it. And here comes question 16, which is the second last question also. At 7:30 a.m., a bus left town P for town Q at an average speed of 60 kilometers per hour. So you have town P and you have town Q, and the bus leaves at 7:30 a.m. That's the bus. And the speed is, let me write it here, 60 kilometers per hour. 15 minutes later, a car left town Q and headed for town P. So the bus was going this way. Now the car is coming this way. And 15 minutes later, so the car is leaving from point Q at 7:45 for point P. The car reached town P at 10:45 a.m. 10:45 a.m. So what's the duration, the time here? 7:45, 8:45, 9:45, and 10:45. So it's basically 3 hours. The bus reached town Q at noon. Noon is 12, right? So how many hours? Time here is 4 hours and 30 minutes, right? 4.5. So we can write this as 4.5 hour. So reading it and making this diagrammatic representation helps in solving. It ensures that we are not missing out any information. What is the distance between town P and town Q? Which information can we use to find that? Here we have time and speed both. So we can use that to find the distance. So we say distance is speed times time. That is equal to 60, this one 60 kilometers per hour, and it's 4.5, right, hours. 4.5. So let's do the calculation here. 45 times 6, that's 33 there. That's 24 plus 3, 27. So this is 270, and that's not 6, it's 60. So we put that decimal. But again, this is not 45, this is 4.5. So we put the decimal there. So the distance is 270 kilometers, right? Kilometers per hour. So we know the distance now. Next part. What was the average speed of the car? Can we find the speed here? Can we? Yes, because we know the time here and the distance is here. So we are going to use that. So the speed here is distance upon time. That is 270 kilometers upon 3 hours. So that's 90 kilometers per hour. Because 3 times 9 is 27, right? And done. Ready for the last one? Yay! Anna can cycle 6 miles in 24 minutes. Zachary can cycle 5 miles in 30 minutes. At her current rate, How many miles can Anna cycle in 14 minutes? So it's 6 miles and 24 minutes, right? So this is basically times 4, right? So this ratio becomes 1 upon 4, which means for every 1 mile, she needs 4 minutes. So in 14 minutes, how many miles can she cover? So this is what? It's 3.5. You can check here, 14 divided by 4. This is times 3 is 12. To remainder, we put 0 there, and that's decimal there, and 5. So we do the same thing here. So this is going to be 3.5 because that's times 1, right? So this is the answer. Part B. At his current rate, how many miles can Zachary cycle in 45 minutes? So again, it's the same type of a question that we have. So we are going to use this. So that's miles and that's minutes. 5 miles in 30 minutes, right? And this is what? Times 6. So 1 mile is 6 minutes. We write 45 here because we need to find in 45 minutes how many miles, right? And that's 7.5. You can check here, 45 divided by 6 times 7 is 42. 3 remainder, we put 0 and a decimal, and that's times 5. So the same thing here, times 7.5. 1 times 7.5 is 7.5 itself. So this is the answer. Here comes part C of the question, and then we are done. Anna and Zachary both cycle from their homes to the library. So Anna's home to library is 5 miles and this one is 3 miles. If both Anna and Zachary start cycling at the same time and they cycle at their current rate, so this is the current rate, right? How long will one have to wait for the other to arrive? Now, this is 5 miles. Let's go here. For 1 mile, it is 4 minutes. So, 5 miles will be times 4, right? Which means that's going to take 20 minutes. Now, here, this is 6, right? 1 mile is 6 minutes. 3 miles will be times 6. That's 18 minutes. So Anna is going to take 20 minutes and Zachary is going to take 18 minutes. They start at the same time. Who is going to reach first? Zachary will reach in 18 minutes and Anna is reaching in 20 minutes. So who is waiting? Zachary is waiting. And for how long? So we say 20 minus 18, right? Which is 2 minutes. So, from these 4 options, Zachary will have to wait 2 minutes for Anna. And it's done. With this, we are done with all the questions. Wow, the review was really quick. How did you feel? Are you confident? Are you ready for the assessment? Great. Whether you are ready or not, I would suggest that rewatch this so that you're thorough and more confident and you score really well. Wish you all the best and see you soon in the content video for chapter 6.1. Keep watching and keep learning. Goodbye.